My name is Jennifer Bell, and today Dee Fitzsimmons and I will explore the use of DNA evidence in court and argue that while DNA is a powerful tool, more caution is needed when using it as evidence in the courts. Deoxyribonucleic acid, better known as DNA, is a powerful tool for identifying individuals due to the uniqueness of each person's genetic profile. Aside from identical twins, no two individuals share the same DNA sequence. DNA can be extracted from a variety of biological samples such as blood, saliva, semen, tissue, and hair. And these samples undergo meticulous analysis where DNA is carefully extracted from cellular material and compared to other samples to confirm or exclude potential matches. The first use of DNA evidence in an Australian courtroom took place in 1989, representing a significant milestone in the criminal justice system. And since its widespread implementation in the 1990s, DNA evidence has profoundly enhanced criminal investigations throughout Australia to not only convict offenders but also exonerate innocent individuals. Today, the National Criminal Investigation DNA database holds over 1.7 million DNA profiles. These profiles have been systematically collected and uploaded by Australian police from a variety of sources, including crime scenes, convicted offenders, suspects, volunteers, and items belonging to missing persons, as well as unidentified human remains. In Victoria, the Crimes Act 1958 allows police to collect DNA samples from any person who is convicted of an indictable offence, and if you are acquitted, your DNA must be destroyed after 12 months. Several innovative techniques have emerged that enhance the use of DNA in the criminal justice system beyond direct DNA matching. Familial searching allows DNA profiles to identify genetic relationships underpinned by the science that parents and siblings share their genetic makeup. This method is beneficial when no matches are found in existing databases. Kinship matching uses the same principles as familial matching, often used in civil investigations involving multiple unidentified bodies, such as aircraft disasters. Family members submit DNA samples to help identify remains faster. Mitochondrial DNA testing is invaluable for identifying skeletal remains, especially when nuclear DNA is too degraded for analysis, and this can also trace geographic ancestry back to specific continents or countries. YSTR profiling assists in familial searches and is useful in forensic cases to differentiate male DNA in mixed DNA samples, used especially in sexual offence cases. The amount of DNA left on an object varies with contact duration and type. Low copy number analysis amplifies small DNA samples from fewer cells. However, it risks contamination, leading to potentially erroneous results. And lastly, DNA phenotyping can predict not only physical traits but some medical conditions. It is the latest in DNA profiling methods. This technique is used in cases without a database match and is regulated in some countries as it raises potential privacy concerns over the detection of medical conditions. However, this investigative tool is used in Australia by police. For ethical reasons, relying on DNA profiling is problematic. Familial searching utilises biological relationships to produce leads for criminal investigations. This practice poses a significant risk of further targeting specific groups, particularly marginalised communities such as Indigenous Australians, who are already disproportionately represented in the justice system. Critics highlight that while familial searching infringes upon the privacy rights of all individuals whose relatives' DNA is stored in databases, the impact of these privacy violations is not uniformly experienced across the population. Existing racial disparities within the criminal justice system exacerbate the likelihood of biased outcomes, leading to a form of genetic surveillance that disproportionately affects those that are already marginalised. This creates a troubling cycle where specific communities face increased scrutiny and investigation, further entrenching systematic inequalities and injustices. The CSI effect has led jurors to overestimate their grasp of forensic science, erroneously believing that crime dramas provide a comprehensive education on the subject. As a result, they frequently conclude that a conviction is unachievable without DNA evidence, perceiving the case as weak and overlooking other compelling evidence that indicates guilt. In 2013, Shandee Blackmore was murdered while walking home from work, and her ex-boyfriend was charged. However, the prosecution could not produce DNA evidence linking him to the crime, despite apparent blood in his car. With no DNA matching either the victim or the suspect, he was acquitted. A subsequent coronial inquest identified the accused as the likely murderer based on all the other evidence. In 2021, investigative journalist Hedley Thomas delved into the case, collaborating with a respected forensic biologist to re-examine the evidence. They uncovered significant errors in the DNA testing process. This revelation sparked public outrage and prompted a government inquiry into the laboratory, which exposed critical flaws in testing methods used at the laboratory since 2012. It indicated that numerous samples with identifiable DNA had returned no DNA results, adversely affecting many cases, including that of Shandee Blackburn. Retesting of DNA samples is ongoing to fully understand the extent of the systemic testing failures.
In Australian legal context, several case studies underscore the importance of caution in the use of DNA evidence. A notable example is Farah Jama, a 19-year-old man of Somali descent who was charged with the rape of a woman at a Melbourne nightclub in 2006. The prosecution's case rests solely on the DNA match between Jama's profile and semen found on the alleged victim. There was no other substantiating evidence connecting Jama to the alleged crime. The case raised serious concerns about the reliability of DNA evidence and whether it could conclusively prove guilt in the absence of any contextual or supporting evidence. Jama's DNA sample was processed at the same time and place as an unrelated sample. This raised the possibility of contamination, an explanation that had not been initially explored. Despite the lack of supporting evidence, Jama was convicted and sentenced to 6 years imprisonment. In 2009, the conviction was squashed after further inquiry revealed the contamination error. In response to Jama's miscarriage of justice, the Victorian government commissioned a formal inquiry led by Justice Frank Vincent, who concluded that Jama had been wrongfully convicted due to the uncritical reliance on DNA evidence without appropriate safeguards or scrutiny. This case became one of the most well-known miscarriages of justice in Australia involving forensic evidence. It highlighted the dangers of over-reliance on DNA without context, and it led to changes in how forensic evidence is handled and presented in Victorian courts, including better lab protocols and judicial awareness of the limitations of forensic science. DNA testing has the power to overturn wrongful convictions by providing objective evidence that can challenge prior verdicts. A notable example is Andrew Button, who was convicted in 1999 of a sexual assault that occurred in Rockhampton, Queensland. The conviction was largely based on eyewitness identification and circumstantial evidence. Button always maintained his innocence. Following the conviction, the Innocent Project took on Button's case and arranged for advanced DNA testing of biological material recovered from the victim. The results excluded Button as the source and identified another individual. This new evidence prompted an appeal. The New South Wales Court of Criminal Appeal squashed the conviction. The court accepted that the DNA evidence fundamentally undermined the prosecution's case and that a miscarriage of justice had occurred. Button was acquitted after having served 4 years in prison. The Button case highlights the power of post-conviction DNA testing in correcting miscarriages of justice. It underscores the fallibility of eyewitness identification and the importance of scientific evidence in ensuring fair outcomes in the legal system. It also reflects the crucial role of organisations like the Innocent Project in pursuing justice. In conclusion, while DNA evidence has transformed forensic science and significantly contributed to both the conviction of offenders and the exoneration of the innocent, it is not without limitations. Its perceived infallibility can obscure critical issues such as contamination, interpretation of complex mixtures, and misuse in the absence of supportive evidence. Miscarriages of justice illuminate the urgent need for a more cautious and informed approach to the use of DNA in courtrooms. This includes oversight, transparent methodologies, and balanced integration with other forms of evidence. At its best, DNA evidence is a highly reliable and objective investigative tool. However, its effectiveness hinges on responsible application. Only by recognising both its strengths and vulnerabilities can the legal system harness the full potential of DNA while safeguarding against the risk of injustice.